Hello coders, welcome to my channel. I am Aniket and today we will discuss the problem equal points in brackets. Let's read the problem. Given a string S of opening and closing brackets and find an equal point in the string. An equal point is a position k 0 based such that the number of opening brackets before position k is equal to number of closing bracket from the position k to the string to the end of the string. So let's discuss it. Let's say the k is this, and from this to this end, the number of closing bracket, let's say it is y, and from before this k to the first, so the number of open bracket, let's say it is x. So for this valid split index k, x should be equal to y. I hope you got this now. The an equal point is a position k such that the number of opening brackets before position k is equal to number of closing brackets from position k to the end of the string, just like this, from position k to the end of the string. If multiple such points exist, return the first valid positions. You have to return the first valid position k if there are multiple positions are exist for a valid split. The string can be split at any position from 0 to n, where n is the length of the string. If we split at 0, it means there is an empty string on left. It is obvious that if we split at n, it means there is an empty string on right. It is also obvious. So what does it mean? Let's say you split at index I. Let's say it is given to you this kind of string. So if you split at here, then there is no string present on its left. And if you split, there is other case also splitting. If you split here, then there is no string uh, after this. There is an empty string on right. So there is an empty string on right. Empty string on right, and empty string on left. So I hope you got this. Here the possible answer for k is only possible k is only between 0 till to end. Now the first question arises is how can you find number of open bracket and closing bracket before the k and after the k. So the question is how can you find the number of closing and opening bracket before, or you can say number of closing bracket before k and number of before k, number of opening bracket before k and number of closing bracket after k. So the brute force method is like for each k, let's discuss the brute force method. How can you do it in brute force? For each k, you traverse from k to the start or start to the k, it is your choice. K to the start to count number of open brackets, and you traverse from k to the end of the array, end of the string to count number of close bracket. So what is the cost of this? The possible k is n, and for each k you traverse left and right, it might be possible that it is always giving you n complexity. For let's say the value of k is n in worst case, and for each k you traverse the whole array. So the complexity for this approach is O of n square. But it is not optimal. It will give you TLE. It will give you TLE. So what is the optimal way to perform the operation such that we can easily find what is the number of open brackets before this k and what is the close bracket after this k. So we can use the prefix and suffix logic. We can use prefix and suffix sum logic. So what does the prefix I store? Prefix I will store the number of open brackets present from 0 to ith index. And what does this suffix I will store? Suffix I will store number of close bracket present from ith to n minus 1th index. I hope you got this. Let's fill the prefix and suffix uh, array for a given string. Let's say the string is given to you is this type. So what is the prefix and suffix array filled for this corresponding string? In this case, what is the number of open bracket till this index? It is 0. What is the number of open bracket till this index? Sorry, the number of open bracket till this index is 1. So the prefix of I will store 1 for this index. What is the number of open bracket till this index? It is also 1. The number of open bracket till this index, it is also 1. Number of open bracket is still this index is 2 because number of open bracket is come again. So it will become 2. What is the number of open bracket till this index? It is 3 because this is an open bracket, so a increment will be uh, a plus 1 will do in this 2, so the number of open bracket will become 3. Now here it is 3, here it is 3, here it is 3. So in this way you can simply fill this prefix I. Prefix I will store the number of open bracket present before 0 to present from 0 to ith index. So for any index, if you are this, if you are at this index, so you can simply uh, see the corresponding value of prefix I, which will give you the number of open bracket before this index, that is 1 2 3. So it also store 3 value. Similarly, what is the value of suffix I for the corresponding string? What is the number of closing bracket before this after this index? It is 1. What is the number of closing bracket after this index? It is 1. So previously it is also 1, so an increment will be held. Number of closing bracket from ith index to the end index, so it is 3. Number of closing bracket till ith index to the end index, it is only 3. And here it is also 3, here it is 4, here it is 5, and here it is also 5. So as you can see, for any index you can simply find the number of closing bracket from ith index to the n minus 1th index simply from this suffix I. So I hope you understand what is the significance of this prefix and suffix I. Let's jump to the code now. Here is my simple Java code, but before that please hit the like and subscribe button so that it will motivate me to make such kind of intuitive video for you. Let's discuss our Java code. Here is my simple Java code. Let's make it white. So firstly, I store string.length into our n variable, and I initialize our pre array, which is denoting the number of open bracket from 0 to ith index. Pre of I will store number of open bracket from 0 to I index, and I will simply populate in such a way Whenever I whenever I see a open bracket, I will increment a 1 from the previous, otherwise I will increment 0 from the previous. Similarly, I will do the suffix sum also. For this suffix sum, I have to traverse from last to first, so I will do the same as in the pre-sum. For this, if suffix sum of 0 is equal to 0, simply return 0. What does it mean? It means that all brackets are only open, all brackets are only open, so suffix 0 will 0, so you can partition here only. This is our answer, k is equal to 0. But what happen if our k is between 1 to n minus 1 range? In that case, we will simply calculate pre of I minus 1, because as the question states that you have to check this value, number of open bracket before this k, so you have to do pre of I minus 1, and number of closing bracket including this I index, so you have to include suffix of I. That's why I use pre of I minus 1 and suffix of I. If it is equal, then it means simply number of open bracket before this index is equal to number of closing bracket after this index including that index also is simply equal. So you will return your index I. If 1 to n minus 1 you still can't find any answer, so you simply return n as your final answer. I hope you understand my code and the intuition behind this code, how I use prefix sum and the suffix sum array to get the number of open bracket present before 0 to ith index and number of closed bracket present from ith to n minus 1th index. How the brute force method is not apply here, which will give you TLE for this uh, problem according to the constraint of this problem, and what is the basic observation for this problem. I hope you understand all of them. Please hit the like and subscribe button so that you will not miss any POTT discussions in future. Thank you for watching my video.